Hello everyone, I am Sujani, faculty in physics at Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss some analytical problems on dielectric materials, mainly based on polarization, permittivity and dielectric constant. So before doing the numericals, let us try to understand the formulae that are related to these terms: polarization, permittivity and dielectric constant. So the first formula we are going to see is the dipole moment. So whenever we have to calculate the dipole moment for a given dipole, we use the formula mu is equal to Q into R, where Q here is the charge, Q is the charge and R is the distance or the separation between the two charges. So I can write R as the distance between the two charges. Now the second one we have is to calculate the polarization. So the polarization P is equal to epsilon naught into epsilon R minus 1 into E. Here epsilon naught is a constant which we call it as the permittivity of free space. Permittivity of free space, that is we take it for air or vacuum, epsilon naught, and its value is always constant. It is 8.85 into 10 to the power of minus 12 farads per meter. And epsilon R here is the relative permittivity. It is the relative permittivity. So how do we get the value of epsilon R? Epsilon R is given by the ratio of epsilon to epsilon naught. Epsilon is the permittivity of the medium and epsilon naught is the permittivity of free space. And E here represents the applied electric field. E is the electric field because of which the polarization occurs. Now the third thing is the susceptibility. What is susceptibility? Susceptibility here is denoted by chi, and chi is epsilon R minus 1. So using this we can also write the formula for P as epsilon naught into chi E. So this implies chi can also be written as P upon epsilon naught E. So chi here represents the susceptibility. It is the susceptibility of the given medium. And then we also have the formula for electronic polarization, alpha E. Alpha E is given by 4 pi epsilon naught R cube. 4 pi epsilon naught R cube, where R here represents the radius of the sphere or the spherical cavity which we are considering. So R is the radius of the sphere. Then we also have the formula for EI, or the total internal field, or we call it as local. EI is always equal to E plus P by 3 epsilon naught. So here E represents the electric field which we have already written here. P is the polarization. P is polarization. And epsilon naught. Epsilon naught is the permittivity of free space, which is a constant. So with these formulas, we will be going ahead and doing numericals on polarization, Then we'll be doing numericals based on susceptibility and also to calculate the internal field. So if you are very clear with these formulae, it is very easy to do the numericals to understand the concept well. So first let us do a very simple numerical based on electric susceptibility and dielectric constant. So what is the question given here is, find the electric susceptibility. We have to find the electric susceptibility of a dielectric gas whose dielectric constant is 1.000041. So first let us write the data that is given. What is the data given and what we have to find? So what we are given here is the dielectric constant, which we represent it by epsilon r or sometimes by k. So this is the notation we use to denote the constants or the physical quantities. So epsilon r is 1.000041. And what we have to find here is the electric susceptibility. So find the electric susceptibility. So what is the formula we have seen here for the susceptibility? What is the formula we have discussed just now? Chi is equal to epsilon r minus 1. So it is 1.000041 minus 1. So this is 0.004. So the susceptibility is 0.000041. So what we try to understand here is, if you are able to know the dielectric constant of a given material, you can calculate its electric susceptibility. Susceptibility here measures the ability of the body to allow the lines of force to pass through it. So you can easily calculate the susceptibility knowing the dielectric constant. Now coming to the second numerical, a parallel capacitor has an area of 100 centimeter square and a plate separation of 1 centimeter. So area of the plates is given and the separation between the plates is given 1 centimeter, and this is charged to a potential of 100 volts. The voltage to which it is charged is also given. So what we have to calculate the capacitance and also the charge on the plates. So let us first write the data very clearly and then we will solve the numerical. So first the data given. What is the data given? Area of the plates, A is equal to 100 centimeters square. And plate separation means whenever we are talking about a capacitor, it has two plates where we consider maybe this is the charge, how it is deposited, and this is the separation between the two plates. So D is given as 1 centimeter. D is 1 centimeter and this capacitor is charged to a potential of 100 volts. So V is given. V is 100 volts. So what we have to calculate now is C, and also we have to calculate the charge. Q also we have to find out. So the data given we have and what we have to find. One more thing now we have to understand is whenever we are doing the numericals, we also have to check the units of different physical quantities. All of them have to be in the same units, and most of the time we do the numericals in SI system. So first, before proceeding to solve it, we will first convert them into SI system. So the area we need to convert into meter square. So it should be 100 into 10 power minus 2 whole square, because 1 centimeter is equal to 10 power minus 2 meter. So we are converting the centimeter square into meter square. So this will be equal to 100 into 10 power minus 4 meter square, or I can simply write it as 10 power minus 2 meter square. So this is very important. Checking the conversion of the units before proceeding is very important. So we have the area in SI unit as 10 power minus 2 meter square. And the same way the distance also has to be written in SI. So 1 centimeter is 10 power minus 2 meter. Voltage is given, C we have to find. Now let us write the formula. What is the formula we have for capacitance? C is equal to epsilon naught A K upon D. Here epsilon naught is a constant we have already discussed while discussing the formula. Epsilon naught is the permittivity of free space, which is a constant. Its value is 8.85 into 10 power minus 12 farad per meter. So we are going to take this constant, and since K is not mentioned, we assume that the dielectric is air in between and K is equal to 1 for air. These two things we have to consider even if it is not given. This is a constant, and because there is no dielectric, we consider it as air and K is equal to 1. So let us do the substitution. So the next step in solving the numerical is substituting the given quantities in the formula. So C is equal to the value of epsilon naught, 8.85 into 10 power minus 12. And the area of the plates we got as 10 power minus 2. So 10 power minus 2 into 1 by D. D is here, the distance between the plates is 10 power minus 2. So 10 power minus 2, 10 power minus 2 gets cancelled. So the capacitance here is 8.85 into 10 power minus 12 farads. So this is the first quantity we have to find. So calculate the capacitance. So the capacitance is 8.85 into 10 power minus 12 farad. So after capacitance, we have to find the charge. So the formula for getting the charge is C is equal to Q upon V. So if this implies Q is equal to capacitance multiplied by the voltage. So Q is equal to C into V. So we now substitute the values of C and V. So 8.85 into 10 power minus 12. This is what we got for capacitance multiplied by the voltage, that is 100. So 10 power minus 12 into 10 power 2. So we get the charge to be 8.85 into 10 power 10 coulombs. So you also have to mention the units. So whenever we are talking about capacitance, capacitance is measured in farad. F stands for farads. And here this charge is measured in coulombs. So the capacitance of the capacitor and the charge stored in the capacitor is also obtained. We have got both the values of C and Q. Now coming to the next one, the dielectric constant of helium gas is 1.0000684. So we are given the dielectric constant. Find the electronic polarizability. We have to find alpha E if the gas contains 2.7 into 10 power 25 atoms per meter cube. So the dielectric constant is given and the number of atoms per meter cube is given, per unit volume is given, and we have to calculate the electronic polarizability. So we'll write the data first. So writing the data gives you a clear understanding of what is given, what we have to find, and which formula we'll have to use. So it is always good to go step by step. So first we'll write the dielectric constant. Epsilon R is 1.0000684. This is the value given, epsilon R. And also the number of atoms per unit volume is given, capital N. Always the number of atoms per unit volume is denoted by capital N. So 2.7 into 10 power 25 atoms per meter cube. What we have to find here is alpha E. What is alpha E? Now let us see the formula. We have already discussed the formula for alpha E. Alpha E is equal to epsilon naught into epsilon r minus 1 upon capital N. So, we are given the value of epsilon r, we are given the value of N, and epsilon naught is a constant. You always have to remember some of the physical constants that are used often in physics. So, it is 8.85 into 10 power minus 12 farad per meter. This we are going to use. Now, the next step is the substitution. So, alpha E is equal to 8.85 into 10 power minus 12. In brackets, what we have, epsilon r minus 1. Epsilon r is 1.0000684 minus 1 by the number of atoms. 2.7 into 10 power 25. So, you can use your calculator and solve the numerical directly. Okay, and whenever you are practicing it, you should be using the calculator so that you will know the functions of the calculator, what all you can use. So, let us simplify this now. 8.85 into 10 power minus 12 into 1.0000684 minus 1 simply gives us 0.0000684 divided by 2.7 into 10 power 25. So, solving this we get 2.243 into 10 power minus 41. This is alpha E, that is the electronic polarizability. Now, coming to the fourth one, a solid dielectric with density 3 into 10 power 8 atoms per meter cube shows an electronic polarizability of 10 power minus 40 farad meter square. So, assuming the internal field to be a Lorentz field, calculate the dielectric constant. So, we have to calculate the dielectric constant here. So, write the data first. Identifying the data and writing it with the correct notation is also very important. So, density here represents the number of atoms per unit volume, which is denoted by N. So, N is 3 into 10 power 28 atoms per meter cube. This shows an electronic polarizability. So, the value of alpha E is given 10 power minus 40 farad per meter square. And we are assuming the internal field to be a Lorentz field, and we have to calculate what? Epsilon r. We have to calculate, and epsilon naught is a constant. 8.85 into 10 power minus 12 farad per meter. So, we are going to use the formula which we have used before. What is the formula we have used? Alpha E is equal to epsilon naught into epsilon r minus 1 upon N. So, one simple tip I want to give you here is, instead of substituting and then transposing, I want you to first get the formula or write the formula for epsilon r from here and then do the substitution. It makes things simple and you will also avoid making mistakes. So, to get epsilon r from here, we will just rearrange the terms. So, I can simply write this as alpha E into N by epsilon naught is equal to epsilon r minus 1. I have taken N to the numerator, epsilon naught goes to the denominator. So, alpha E into N by epsilon naught is epsilon r minus 1. Since we want to find epsilon r will be equal to what? Alpha E into N by epsilon naught plus 1. So, let us do the substitution now. Alpha E is given 10 power minus 40. N is given 3 into 10 power 28, and epsilon naught is a constant, 8.85 into 10 power minus 12 plus 1. Whatever value we are getting, we have to add. So this is, if you are using your calculator and simplifying this, you will get 0.339 plus 1. So this is nothing but 1.339. And epsilon r is the ratio of two similar physical quantities, that is epsilon upon epsilon naught. So it's a ratio and it does not have any units. So no units for epsilon r. So the epsilon r value is 1.339. Now one more numerical on capacitors. So a parallel capacitor of area 650 millimeters square and a plate separation of 4 millimeter has a charge of 2 into 10 power minus 10 coulomb. And when a material of dielectric constant 3.5 is introduced between the plates, what is the resultant voltage? So we have to first identify and write the data correctly. So what is the area given? Area is 650 millimeter square. Area. So it is given in millimeter square. And the plate separation, that is the distance between the two plates, is 4 millimeter. And the charge is given here. Charge is given in coulombs. 2 into 10 power minus 10 coulombs. And the dielectric constant epsilon r or k, both mean the same, is 3.5. We have to calculate the resultant voltage. We have to calculate the voltage. Again, epsilon naught is a constant, 8.85 into 10 power minus 12 farad per meter. So now let us write the formula. C is equal to epsilon naught AK by D. But what we have to find here is the voltage. So we will use the other formula for C as C is equal to Q by V. So we can equate these two. Both are the formulae for capacitance. Left hand side is the same. So the right hand side should be equal. So I'll write epsilon naught AK by D is equal to Q by V. So from this we can deduce the formula for V. So V will be equal to Q into D upon epsilon naught AK. This is what I told you have to do. Whatever quantity you have to find, first you try to deduce the formula from the known formulae. So it becomes simple and also error free. So V is equal to Q. What is the value of Q? 2 into 10 power minus 10. And the distance, this is given in millimeter. As I told you in the previous numerical, we'll have to check the units and always see that they are in the SI system. This is in coulombs, SI. But these two also we have to convert now into SI. So 650 into 10 power minus 6 meter square. So 1 millimeter is 10 power minus 3 meter. Minus 3 whole square gives us 10 power minus 6. So 4 millimeter will be 4 into 10 power minus 3 meter. So these conversions are also very important. So D, we'll write it as 4 into 10 power minus 3 upon epsilon naught 8.85 into 10 power minus 12 into area. Area is now 650 into 10 power minus 6 into the value of K is 3.5. So once we have substituted all the values, we will simply use the calculator and get the value 39.73 volts. So the voltage across the capacitors is 39.73 volts. Now coming to another problem on relative permittivity. We are going to calculate the relative permittivity. So if an ionic crystal is subjected to an electric field of 1000 volt per meter and the resulting polarization is 4.3 into 10 power minus 8 centimeter square, calculate the relative permittivity. So we will write the data first. Electric field is given, E is equal to 1000 volts per meter, and the polarization is given P as 4.3 into 10 power minus 8 centimeter square. We have to calculate epsilon R for NaCl. And you know epsilon naught is a constant. 8.85 into 10 power minus 12 farad per meter. So here, when it comes to the units, this is in SI, volt per meter. Polarization is given as a 4.8 into 10 power minus 8 centimeter square. So we need to convert it into meter square. So 4.3 into 10 power minus 8 into 10 power minus 4 meter square. 1 centimeter is 10 power minus 2 meter. So it is 10 power minus 4 meter square. So what is the formula we are going to use now to calculate epsilon R is P is equal to epsilon naught into epsilon R minus 1 into E. Because we are given the value of P, E and epsilon naught is a constant. So we can directly find the value of epsilon R. So how do we write the formula for epsilon R from here? So P upon epsilon naught E is equal to epsilon R minus 1. So epsilon R will be equal to what? P by epsilon naught E plus 1. So let us substitute now. What is the value of P? We got 4.3 into 10 to the power of minus 12 because we have minus 8 here and minus 4. So a power m into a power n is a power m plus n. Simple formula we use. So 10 power minus 12 divided by epsilon naught. 8.85 into 10 power minus 12 into E. E is 1000 volt per meter plus 1. So when you simplify using the calculator, you will get 4.86 plus 1. P by epsilon naught. So the answer will be 4.86. Now coming to the seventh one, calculate the electronic polarizability of neon. The radius of the neon atom is 0.158 nanometer. And the value of epsilon naught is 8.854 into 10 power minus 12 farad per meter. So write the data. We have to calculate the electronic polarizability. Radius of the neon atom is given 0.158 nanometer. Epsilon naught is also given here, even though it is a constant. 8.854 into 10 power minus 12 farad per meter. What we have to calculate is alpha E. Electronic polarizability. Alpha E we have to calculate. So what is the formula for alpha E when R is given? Alpha E is equal to 4 pi epsilon naught R cube. 4 pi epsilon naught, all these are constants and the value of R is given, but it is given in nanometer. So we will convert this nanometer into meter. So what is 1 nanometer equal to? 1 nanometer is 10 power minus 9 meter. So before substitution, we need to convert it into SI. So now coming to the substitution, alpha E is equal to 4 into the value of pi, 3.14 into epsilon naught, 8.85 into 10 power minus 12 into r cube. What is the value of r? We have 0.158 into 10 power minus 9 whole cube. This is the value of r. So simplify, we get alpha E is equal to 4.386 into 10 power minus 40 farad meter square. So this is the value of alpha E, that is electronic polarizability. Now coming to the next one, 8th one. Calculate the polarization produced in a dielectric medium of dielectric constant 6 subjected to an electric field 100 volt per meter and epsilon naught is 8.854 into 10 power minus 12 farad per meter. Again, this is a simple numerical based on the formula we have already used. Okay, so the dielectric constant is given. Dielectric constant is 6. So we'll write epsilon r is equal to 6. It is subjected to an electric field of 100 volt per meter. So E is given. E is how much? 100 volt per meter. And the value of epsilon naught is a constant, 8.854 into 10 power minus 12 farad per meter. What we have to calculate here is P, the polarization. What is the formula we have for polarization? P is equal to epsilon naught, epsilon r minus 1 into E. So this is the formula we are going to use. So P is equal to the constant 8.854 into 10 power minus 12 into epsilon r is given 6 minus 1 into E. E is 100. So I can simply write it as 8.854 into 5. 6 minus 1 is 5. 10 power minus 12 into 100 is 10 power minus 10. So the value we get is 4.425 into 10 power minus 9 volt per meter square farad. So this is the value of polarization. Now the next one, a solid contains 5 into 10 power 28 atoms per meter cube with a polarizability of 2 into 10 power minus 40 farad meter square. Assuming the internal field is given by the Lorentz formula, calculate the ratio of internal field to external field. So we have to calculate the ratio of EI to E. EI is the internal field. We call it as local field or internal field, and external field is always denoted by capital E. Epsilon naught value is given at 8.854 into 10 power minus 12. So we'll write the data first. Capital N is given 5 into 10 power 28 atoms per meter cube. These are the number of atoms per unit volume. And then the polarizability is also given, alpha E, 2 into 10 power minus 40 farad meter square, and epsilon naught is given 8.854 into 8.854 into 10 power minus 12 farad per meter. And what we have to calculate is EI upon E. That is the ratio we have to calculate. EI is the internal field and E is the external field. So let us first write the formula. So formula for EI. So EI is always equal to E plus P by 3 epsilon naught. So first we will substitute for P. So P is equal to N alpha EI. So this implies E plus N alpha EI upon 3 epsilon naught. So we will write the terms with EI on the left side. So what we have is EI minus N alpha EI by 3 epsilon naught is equal to E. I can take out EI common here. So EI into 1 minus N alpha by 3 epsilon naught is equal to E. So EI upon E will be equal to 1 upon 1 minus N alpha by 3 epsilon naught. So this is the formula we have got for the ratio. So now let us do the substitution here. So what we get for EI upon I is 1 upon 1 minus N. N is how much? 5 into 10 power 28 into alpha is 2 into 10 power minus 40 by 3 epsilon naught, 8.85 into 10 power minus 12. So this is there in the denominator, 1 minus N alpha by 3 epsilon naught. So the ratio, you can directly use your calculator to get this value. It will be 1.604. So 1.604, we are getting the ratio of the internal field to the external field. Next one, a layer of porcelain is 80 millimeter long, 20 millimeter wide and 0.7 micrometer thick. Calculate its capacitance when epsilon r, that is the dielectric constant, is equal to 6. We have to calculate the capacitance. So let us now write the data given. Length is given 80 millimeter. Breadth is given, that is wide, 20 millimeter. And the thickness is given, we will consider it as D or T. T or D. Thickness or D, or you will call it as H if you are taking it as a cuboid. Okay, is 0.7 micrometer and epsilon r is 6. Epsilon naught is constant. 8.85 into 10 power minus 12 farad per meter. So the first thing we'll do is we will convert these millimeters into meters to write everything in SI system. So the length will be 80 into 10 power minus 3 meter. Breadth will be 20 into 10 power minus 3 meter. And the thickness is given in micrometer. Micro is 1 micrometer is how many meters? 10 power minus 6 meter. So we have written this in micrometer. And epsilon r is equal to 6. Epsilon naught is a constant. So what is the formula we are going to use now? C is equal to epsilon naught A K by D. K or epsilon naught, both mean the same. So C is equal to epsilon naught A K by D. We have epsilon naught, we have the value of K, we have the value of D. So how do we get area? Area is nothing but length into breadth. So I can write this as epsilon naught into length into breadth, which gives the area multiplied by K upon D. So this formula we'll take and do the substitution. So C is equal to epsilon naught is 8.85 into 10 power minus 12 into length 80 into 10 power minus 3 into breadth 20 into 10 power minus 3 into K is 6 upon D 0.7 micrometer, that is 10 power minus 6. So simplify, you get 1.21 into 10 power minus 7 farads. So this is the capacitance. Or you can also write it in microfarad as 0.121 into 10 power minus 6 farad, or just to know the conversions, 0.121 microfarad. This is the capacitance. So for more numericals, you can refer to the solve problems given in this link. You can use this link, the third one and the second one also. And for any clarifications regarding the concepts, you can, or the formulae, you can use Introduction to Electrodynamics by David J. Griffiths. So once you are clear with your concepts, you can use the formulae and do the numericals provided in these two links. So thank you and see you again.
Like, share and subscribe. Hit the bell icon for more updates.